Dear friends, in this video, we will discuss hypothesis testing and decision making at a conceptual level, starting with sampling distribution and central limit theorem. Before we proceed to hypothesis testing and drawing inferences, it is important for us to understand sampling distribution and central limit theorem. Central limit theorem is the cornerstone of statistical inference. All parametric tests, by and large, involve the assumption of central limit theorem. Let us now look at some of the basic concepts associated with that central limit theorem and sampling distribution. Sampling distribution is the possible probability distribution of all values the sample statistics can take. In other words, it is the probability distribution of all the possible values a sample statistics can take. Statistic in sampling means the summary measure based on sample, such as sample mean and sample proportion. So the word statistic implies the summary measure based on the sample which we draw from a population. So if you are able to generate, for example, the distribution of all possible X bars, let us say X bar is the sample mean. For one sample, I can compute X bar. For example, if I take a sample of size 20, I can draw from the population a sample of size 20 and compute X bar. Another sample of size 20 randomly I take and compute X bar. There are several ways I can draw a sample of size 20 from a population, and I will generate a number of X bars. The distribution of all those X bars which I generate is called the sampling distribution of the mean X bar. So let us now formally define this. If X1, X2, X3, etc., Xn are n independent random samples drawn from a normal population with mean mu and standard deviation sigma, then the sampling distribution of X bar follows a normal distribution with mean same as the original sample population, mean mu, and the standard deviation sigma by root n. Let me repeat this. We are making the assumption the original population is normally distributed. So from that normally distributed population, if I draw a random sample of size n and compute the mean X bar, there are several ways and possible combinations I can have, each combination having a sample size n, and I generate a number of X bars. Then the distribution of X bar follows a normal distribution with mean mu and standard deviation sigma upon root n. Sigma upon root n is known by the term standard error. So this is the definition of sampling distribution of mean when the population is normally distributed. What is the guarantee original population is normally distributed? It is not necessary. It could be a skewed distribution. So it could be a very tall distribution. It need not be a bell curve. And therefore, what do we do when we have to do hypothesis testing? We need the property and the assumption of a bell curve of the population. Now, if the population is not normally distributed, what do? we have a wonderful milestone landmark discovery called the Central Limit Theorem, which says regardless of the shape of the original population, the sampling distribution of the mean will approach a normal distribution when the size of the sample increases and becomes large. Whatever be the shape of the original population, if I draw a random sample of size n and compute x bar, in a repeated manner, I keep on computing a random sample of size n, keep on drawing a random sample of size n, and keep on computing x bar, then the distribution of such of those x bars that I have generated will still be a Gaussian normal curve, regardless of the shape of the original population, provided the sample size becomes large. So if the sample size gets larger and larger, then the distribution of x bar will approach a normal distribution, whatever be the shape of the original population. This is a landmark discovery called the Central Limit Theorem. And the question is, how large is large? We see in this picture, as the sample size increases, this is the original population. It becomes, by virtue of the application of the Central Limit Theorem, the bell curve. In other words, the sampling distribution of the mean approaches normality when the sample size increases and becomes large. Theoretically, it is infinity, but practically, how large is large? This is a question which we have to answer. A thumb rule or accepted convention is a threshold sample size of 30 and above is considered large. In other words, you qualify to apply the Central Limit Theorem if the sample size which you can consider from the population is 30. It does not mean 30 is the best. It is a qualifying threshold number. So the desirable sample size for a particular population depends upon the sampling error and the confidence level which you would like to have. For example, if I specify the sampling error to be a number, and that should be kept always in mind. In other words, the sampling error should not exceed number 3, for example. Sampling error is nothing but the difference between the estimate and the actual. If the sampling error should not increase or go beyond 3, and that should happen with the probability of 95% of the time, then what should be the sample size? Statistically, we can determine, and we will see those things later. For the time being, a threshold sample size of 30 is accepted for the application of the Central Limit Theorem. Let me summarize again. Regardless of the shape of the original population, if I take a random sample of size n from any population, which may not be normal, whatever be the shape, and if I keep on drawing a random sample of size n, and if I keep on computing x bar, then the distribution of x bar will be a Gaussian normal curve as the sample size becomes large. In other words, if the population mean is mu, the standard deviation is sigma, you will have the sampling distribution x bar with mean mu and standard deviation sigma by root n, which is called the standard error. In other words, this is the milestone discovery called the Central Limit Theorem. And let us look at associated concepts of hypothesis testing. In the next video, we will proceed very soon to the next topic. Thank you very much. Yeah. Mom. சீக்கிரம் இன்னைக்கு முடிஞ்சுட்டா?
ஆமாப்பா, அந்த நேரம் வீட்டுல இல்ல.
சரி சரி
அதனால இல்ல.
சரி ரைட்.